This is the solution video for Unit 9 review problem number 1. All right, so let f be the function with the first derivative given by f prime of x equals 2 sine of x squared minus x for x between 0 and 3. For what value of x does f attain its maximum value on the closed interval? All right, so we're given a derivative, right, f prime, and we want to find the maximum, right? So now, remember, if we're thinking about a graph of f, right, let's say something like this, right, the maximum could occur at a local maximum, or it could occur at an endpoint where the derivative is positive leading up to it, or if we had a graph that went like this, it could be at an endpoint where the derivative is negative after it, right? Or at a local max, right? So what we want to do is we want to get a graph of this f prime, all right? So now let's go to our graph, 2 sine of x squared minus x. So now I've got my calculator here. So 2 sine of x squared minus x. All right, and so we're going to graph that. Now, when I graph this doesn't tell us exactly what we want to see. Okay, remember, we want for x between 0 and 3, so we need to change our window for x between 0 and 3. And then my y values, right now I have negative 2 to 3. Let's see if that's good enough. All right, that is sufficient, right? And so what we want to do is we want to get, we want this picture. So I'm going to grab that. All right. All right, so we have this now. All right, so now what we want to do is we want to think about where a maximum could occur, right? So we've got our endpoint here. We've got this, which looks like it's 1. We've got this here, and then we've got this other endpoint, right? So now let's think. Derivative, this is the graph of f prime, right? So the derivative is negative, then positive, then negative, right? And so negative means decreasing, then this would be a local minimum. So we have an endpoint, local minimum, okay, then positive, then local maximum, right? And then negative again. And so then we go to our endpoint, right? So now where could it occur? Well, it could occur right here at 0, okay? It couldn't occur here at 1 because that is a local minimum, but let's just call it A until we find that point officially, all right? It could occur here at B, right? Because that would be a local maximum. And here at the endpoint of 3, it could not occur there. That could be a minimum. So really, it's 0 or B. All right, so now we need to find A and B. All right, so let's go back to our calculator. All right, and we're going to do second trace 0. All right, left bound. So I'm going to put my cursor on the left of that, like how about at 0.5? I could type it in. And then to the right of it, how about 1.5? All right, and so, okay, and it ends up being 1 like we said, all right? But then second trace 0, all right? Now over here, let's say from 2, and then let's say like, I don't know, how about 2.5, all right? And so now this 0 in between there, we get 2.342. Okay, 2.342. So let's put that onto our graph. So we have A equals 1 and B equals 2.342. All right, so now we said it could be 0 or B. And so what we're going to do is we're going to integrate from 0 to 2.342, the f prime equation. And that's going to equal f of 2.342 minus f of 0, right? And so now let's do that calculation. So go back to our calculate screen, all right? And we're going to do math 9, and we're going to go from 0 to 2.342, all right? And then our equation here, I'm just going to grab the y1 equation. So I'm going to go to vars, y-vars function y1, all right? So y1, and then with respect to x. All right, so now I integrate and I get 1.258. So this integral is 1.258, right? So 1.258 is f of 2.342 minus f of 0. Right now, the key is that this thing equals a positive number. So this thing is greater than 0, which means that f of 2.342, right, if we add f of 0, right, we get f of 2.342 is greater than f of 0. So where does the maximum occur? Well, the maximum must occur at x equals 2.342. Why? Because f of 2.342 is greater than f of 0. So max occurs at x equals 2.342.